Good evening. It's a great pleasure for me to welcome you all at today's webinar, which is the first one for this session. I'm really happy to do this honor, and I welcome Dr. Nadunalis, our resource person for today, who accept the invitation with wholeheartedly. So I also welcome our Deputy CEO, Engineer Gunwadana, and council members, Engineer Niaz, Engineer Manjul Samrat Singh, and our Honorary Secretary, and members who are physically here attending this webinar, and those who are attending online. I welcome everyone for this webinar today. Before commencing today's event, let me brief you about the Civil Engineering Sectional Committee main activities what we are planning to do. We will be conducting technical presentations and non-technical presentations on Tuesdays and most probably on Thursdays. And there may be changes with these days, but Wednesdays we have kept for non-technical presentations, technical presentations on Tuesdays and Thursdays. Apart from these, we will organize field visits, including technical things, tours, CSR programs, CPDs, and we are looking at this techno at the annual session thing. And I request you all to come with appropriate topics with suitable resource persons to handle this year events. I suggest all of you to be with us and share whatever the things we are doing in this year and update ourselves and do the honor to the country. Let me come to today's event organized by our Civil Engineering Sectional Committee under the title Design and Construction of Post-Tension Box Girder Bridges, Holistic Approach. This presentation focuses on giving a holistic view of the design and construction process of bridges. I state few words that how our resource person look at it. He says a bridge is not a piece of abstract art. It is a structure which has to satisfy a need, get built and be durable, maintainable and should be economical. And the design has to start with this in mind. It's very beautifully said, and it's very acceptable. In this presentation, Dr. Nadun will give you an insight view of this process with some of the key design and construction challenges of post-tensioning concrete bridges, hoping that these ideas will be of use in developing the bridge sector in Sri Lanka. With this enormous knowledge on this sector, I hope Dr. Nadun will accept to conduct a series of lectures under this topic in another platform at a later date that will benefit our members who are actually seeking their upliftments on their ladder in these professional careers. So, knowledge of developing the designing and construction of which Sri Lanka can be updated, uplifted from this type of seminars, webinars. So, thank you, Dr. Nando. I'm definite that this would be a very impressive and effective webinar for you as the civil engineers, and most probably all of you are from the industry. So, to do this instigating note about our resource person, though he is a well-known person to us, I invite Engineer Banduka, coordinator of the technical sessions, who is chairing these knowledge sharing sessions, to proceed the event with an instigating note to introduce our resource person. Over to you, Banduka. Thank you.
Hello, everyone. Today, our speaker, Dr. Nadunalis, is a graduate from the University of Moratuwa with a first-class degree and titled as the Best Civil Engineering Graduate for the academic year 1998. And he received the UNESCO Team Award, gold medalist for his academic achievement, and won the full scholarship to read his PhD at Cambridge University, UK. He published many papers and presented his work at conferences and won awards for his research. And Dr. Nadun is a chartered civil engineer, majored structural engineering, and having more than 22 long years of wide-ranging experience in highways, transportation, oil and gas, offshore wind, building and tunneling sectors, and has built a strong technical reputation in delivering high-profile, complex projects across the globe. He has been working for multidisciplinary companies under different capacities, principal bridge engineer, team leader, and many more, gaining valuable hands-on experience and in-depth sector knowledge. Dr. Nadun has led a variety of major highway projects covering all phases like feasibility studies, design, construction, and maintenance across the globe, with a variety of bridges, viaduct structures for highways, rail, and light railway projects. In 2017, he migrated to Sri Lanka and has been working as a senior deputy general manager at Marga Engineering Private Limited for nearly 2 years. He has recently completed his assignment as the international structural consultant for the Central Expressway Project Section 1. And Dr. Nadun is an experienced business and project leader who is responsible for managing key clients and varieties of projects. He is a fellow of this Institution of Civil Engineers UK, member of this Institution of Engineers Sri Lanka, and also a member of the Society of Structural Engineers Sri Lanka. And over to you, sir.
Good evening, everybody. First of all, I should thank Engineer Mrs. Kamala Gowardhan for inviting me and asking me to come and do a presentation. And also, some time back, actually, Professor Jasing also asked me to come, but at that time I was really busy of my assignment. So I said that when I get an opportunity, I'll come and talk. So when the invitation came, I was thinking, what should I be presenting today? Which is, in a way, just want to give a message to our young engineers and those who are working in the industry. And then, after a lot of thought, I thought I would touch base on that design and construction of post-tension square bridges and just the holistic approach. Because I just want to talk about the overall process which involves the design, right? And I'm not getting into detail of the design itself, but the process is the one that I wanted to highlight. Because, we are going through unprecedented time in Sri Lankan context, and I know many engineers wanted to go abroad for employment, but what's out there? And but I thought, because I've been away for about 18 years in UK, and while working in Sri Lanka, I see that certain gaps. Maybe that while sharing this, some of my ideas may be useful for you to get engaged with when you go abroad and also practice in Sri Lanka too. So on that note, it's just bear with a minute. That freezes. It's moving. Oh. Thank you. Sorry for the site technical glitch, but nonetheless, now we carry on this one. So my presentation would be like, I would touch base on the introduction to bridges, and predominantly I'm going to talk about this design process, as I mentioned to you, and also some of the design and construction challenges of concrete box girder post-tension bridges. Also wrap up with some thoughts. When you look at that types of bridges, of course, you see variety. I mean, when you walk around the city, and there are so many types. But what I wanted to emphasize is none is possible without the understanding of the materials. So if you look at the history, I mean, if you look at the overall types of materials, we have wood, bricks, concrete, and steel. And the beauty is the composites as well. The understanding of this material, push boundaries, and then development of the technology and etc. And this gives the open up many opportunities for engineers to come up with fascinating structures, marvelous bridges, right? On that note, I would like to share a few bridges. This is one in Cambridge. If you happen to be in Cambridge, definitely you will not miss this one. Because when I studied there, that in the Cambridge itself is a village, that there are so many colleges around, and we call a river camp. And underneath the river camp, I mean, people do what you call the punting. You go on a boat and then you use a stick and push against the riverbed. And then the summertime is fascinating, and the people actually enjoy themselves there. So you will definitely go under this bridge. What I see with this bridge is, as I showed in the picture below, it's the bridge itself has lots of compressive struts, which that's how it works. It's but there's a myth actually. It's been saying that it's been done by it's actually a Newton's bridge. It's not the case. We call it Cambridge Mathematical Bridge. This has been rebuilt number of times, but it's standing right now. So don't miss it when you happen to visit that site. And recently, actually, I noted this one from the BBC documentary, which is in Carrow Bridge. What fascinated me is that this is being done every year, and they use some kind of straw woven by hand, and the people get together that area, and then they build this bridge. And it's been about, you know, this has been practiced about 600 years. So if you look at the context of the technology, they would have known that it's not been documented, but with the experience, they know how to build a bridge. People walk across at the end of the day, and they've been using them. Now, this one is in Scotland, right? If you happen to be UK again, north side of UK, and it's a beautiful bridge built in 1890. What fascinated about this structure is, if you look at that time, they haven't had that the computer analysis or computer modeling available, but they use the fundamentals. There was an article, it says that that time, when they came up with this idea, they want to demonstrate that it works. So that's the three engineers got together, and they showed that how the load path actually distributed, and showing that the bridge is stable. And what I wanted to emphasize here is that if you are a young engineer or a professional, but you need to understand the fundamentals. That is a key aspect. If you know the fundamentals, with the available technology, you can use any software. That is a matter of understanding the software. But if you don't know the fundamental, then you will be in trouble. Because there's a misconception saying that people know how to use the software. They think they are the engineers. Apparently, unfortunately, that's not the case, because you need to know what to look for, how the structure works, and etc. Right? And as I said, that when it comes to recent developments, people get to know about the advancement of the material, likes of high strength concrete and pre-stressing tendons and proper anchorages and constructions, like, for example, the crane capability. The more you get advancement in the industry, people tend to push boundaries. That's what happens. You get launch span bridges, very high bridges. The picture below is we call the Milan Viaduct in France. It's a fascinating structure. On a cloudy day, you're flying through that clouds, right? How people achieve that? It's because of understanding of this technology. I wanted to show you this picture. This is being done as part of the Millennium Celebration in UK. this is about the county council of that area. They want to come up with, they want to have a bridge because the requirement is such that it's needed for the people to cross over the bridge, as well as you need to facilitate the navigation. And how they came up, they opened up that for a architectural competition, right? All the architects got together and it was a competition, and they won by that process. Then only they went with the design of that bridge. So this is a good example of how the architects and the engineers can collaborate and come up with a fascinating structure. Okay, now that's actually what we see in there, but let's have a bit of a look at like what's happening in Sri Lankan context. And in Sri Lanka, of course, we have a proud history of bridges. Probably you would have seen that stone bridge in Anuradhapura, you know, built in, not to be built in around 1000 AD. If you look at that structure carefully, it's very similar to what you see in the Central Expressway as well. You see that two columns and a capping beam and a beams. So that's what it says here. People knew that. People knew that time. Unfortunately, it's not documented, but we had a proud history about that. Then on the right-hand side, I have to mention about that Nine Bridge. That's one of the famous bridges. And that it's been built by the British. And how they got that idea, if you happen to be in UK, if you drive around that, you see many arch bridges. That concept is there, right? So what about the recent structures, what you see in Sri Lanka? Yes, thankfully, things are coming now to Sri Lankan context. We are blessed with to have wonderful structure across the new calendar. We call this extra cross bridge, right? Fascinating structure. And then obviously next to the structure, there's another element which is called it's a steel bridge. I talk about this one a little bit later in the presentation. But what I want to emphasize is these are coming now to Sri Lanka. My question to you is that yes, we are getting, it's being built. Do you know, are we following the right procedure? Do we have the right experience to undertake these bridges for Sri Lankans? Do we have a knowledge gap? These are the things you should ask yourself, right? I'm sure that by talking to people involved, and that's companies, that foreign companies, actually they come and help us. And to a certain degree, of course, we have talented engineers. They are going through this process and understanding. That is good. Knowledge transfer is happening now. It's good to know that. But this is the crunch of my presentation today. So if you have these bridges, what I wanted to emphasize is, what is the procedure we should follow to achieve these ones? So on that note, let's follow on my presentation a little bit further. So as I mentioned, this is the process that I wanted to emphasize a little bit more. Let's look at this picture. What you see is that a study being done, there was a requirement such that they want to come up with a bridge structure across this river. If you look at, there are a number of options are available. So many options are available. So how do you go by? How do you select the bridge which is suits for the site conditions, which is functionable and economical structure? What is the procedure you should? Just I want to pause a little bit and think about yourself, like what you should be doing. So to me, the way I look at this, it's an iterative process, right? And good bridge design is a holistic response to the site. It wouldn't come all of a sudden, right? So you need to follow these procedures. Now start from the beginning, right? You can say top one. You need to gather facts. There may be technical constraints, aesthetic constraints, requirements. It can be political or historical, right? Then you go to the next box, which is you need to go and look at that root sensitivity, function of the bridge, what material you choose, what method of construction you should adopt, and things like that. Then you come to the next stage, which is called the explore options, which I will talk about a little bit in detail, but this is where we get the value engineering and etc. Then you have a bunch of team, which have designers, architects, contractors, stakeholders. What I want to tell you is this being practiced in developed countries, I would say the UK. Each and every point is going through, right? And don't think that you go one cycle would give the answer. No, you need to do number of cycles and to understand the requirement. When you know the question, when you know the requirements, what to do, then only you can proceed. This is what I feel. And we'll talk about this concept a little bit more with certain examples. Then you get these ideas into your head, right? Now, if you work in a design company, or it can be building, or it can be bridges, or anywhere, but basically the broadly you can categorize into 5 areas, which is, as I shown here, brief assembly, or called the feasibility study, option identification, option selection, design in detail, and construction and maintenance, right? So these are the fundamentally the broader sense you see that. Why this is important is because if you don't follow this procedure as I shown here, there may be so much repercussions. For example, this is what we call the cost of change. Now, on the x-axis, you see feasibility, concept, detail, construction. But the penalty you would get if you wanted to do a change at the last stages, it's huge. So why don't you spend more time on that feasibility and concept? This is what we should be doing. I give an example that, as I mentioned, I've been working in the offshore sector as well, offshore engineering, and you get very harsh environments. You see the wind farms and some of the oil and gas platforms installed in the seabed, right? You know that installation cost is humongous, right? You need to spend about $500,000 US or $1 million US a day for a vessel. It depends on the vessel. If you do that kind of things, and you develop something, you go and try to install it. What would happen if something goes wrong? Repercussions would be huge. So I think this is what I want to encourage even Sri Lankan context. We should put more effort in the feasibility and concept stage and do the right thing, and then you come up with the best answer a little bit later. Now, what do you look into this feasibility stage? Yeah, some of the consideration, but I think it's difficult to write up a definitive list. But just to start up with that, there are certain areas I would say that you should be looking into, as you see from this slide. But we will go through a little bit in detail, discussing each and every aspects. Okay, this now. As I emphasized to you that the feasibility and concept design is a very important stage of any design you are going to undertake, because when you spend a little bit more time on it, you would understand the client objectives, requirements, and the constraints that will enable you to come up with a good structure which is suitable for the location. Right, and I think personal view is that experience is also very important, because sometimes you should understand the sizing, whether that structure works, and etc. It comes with the experience as well, right? I tell you why this is important. Yeah, here also I said, like in a vital phase, most difficult in design or originate from oversights at concept stage. I don't know whether you probably encounter these scenarios in your lifetime and what you do, right? Now, you should be also looking into buildability and constructability aspects as well when you at this stage. I wanted to tell you, like, why this experience matters. This is something I observed. Now, for example, that of course, after my graduation, I went abroad and did my higher studies. And then all my life I've been in the industry. When I first joined the company in UK, right, they took me as a graduate. Although I had that higher qualification would not count at all. The experience counts. That's what it matters there. So I had to learn hardcore, hands-on experience. Then only you get the confidence, and then only you get into some of the decision making. So especially when you hopefully you get an opportunity when you go abroad or here. But when this feasibility and concept stage, very important that you have to have that hands-on experience. Then only you come up with the best solution there. This is my personal view and my personal experience. And then, so what I'm going to do right now is, we went through that, the process, that high-level process. Of course, we'll take an example and explore this a little bit more, right? Now, this is a Central Expressway project. I'm sure that most of you know about it. We have few phases: phase 1, phase 2, phase 3. Phase 2 is Mirigam to Kunagala, which is operational. And of course, if you want to travel, you can see it's a nice structure built by all the local contractors. And then when I was working for Marga, I was supporting the design team in Section D. Most of the structures actually being built in Kunagala. That my team, I was the team leader and headed by some of the other engineers. We did it, so which is very good. So that confidence is there. Then I got the opportunity to move on to phase 1, which is I was a structural consultant. And it's a big project. And again, quite a lot of structures are there, 15 kilometers of viaducts. It includes viaducts, bridges, overpasses, underpasses, everything, right? I'm not going to talk about in detail those things, but I wanted to tell you that how this process works with a certain aspect of that project. That's what my objective is today. Now, what is the objective here? Of course, any trace that you would have come across is not a straightforward line, right? It needs to go through certain bends and etc., depending on the EIA and then other requirements. And that particular location, the main trace crosses the railway at an angle. It's not, I mean, perfect scenario would be that the main trace should cross the railway perpendicular. Then you can come up with a nice bridge, easy bridge. But here it crosses at an angle. Now this problem presented to us. Now, how you come up with a proper bridge design here? How you find a good structure response to the site? Let me go through with you some of the things that how we address that. Now, in a schematic point of view, this is in nutshell what you see. The blue one is the Central Expressway line. The other one is a box that I put it in a schematic manner. It's the railway line. So you need to cross. And then we have a skew span, which you need to tackle through, right? In fact, that this issue is happening at 3 locations, but don't worry about that too much on the details. But think about the context here, that we need to come up with a structure suitable for this location, right? How do you go? First thing, as I said, like feasible study, data gathering. You must do that. You need desktop study. Obviously, you need to go to site and see what are the conditions. So by myself and the people who work under me, so we all went there. And then with the contractor, of course, and see the investigator at the site, what are the constraints, just to get a feel of the site, okay? And then you start talking to the stakeholder, which I come back to in a minute. The important thing of this exercise is identify the requirements, technical, commercial, and time. Reason I mentioned that, you cannot do research here. When you work in the industry, you are not allowed to do research. You need it's time bound, and the commercial constraints are there. So that's one of the things. And important aspects are the key documents. Now, this is what we say in the youngsters when you go to their training. You should read this. How you contractually operate. So this is done by underfeeding, and it's a design and build contract. How the payment mechanism works, because you are wearing which hat? Are you wearing the client hat? Are you wearing the contractor's hat? Are you wearing, I represent the engineer? These are things you should know, how we operate, what context, and how you put the pressure, and etc. But that ultimate goal for us should be, we want the best bridge. We want the right thing. Right? And so please go through this tender documents, preliminary drawings, codes, and etc. So that's a starting point. And then I mentioned to you, there are a number of stakeholders, any projects you get involved. So in this instance, that we had to deal with rail authority, and we had so many discussions. I cut it short, but I'll come to the point in a minute. And then anyway, the stakeholder involvement is also difficult to generalize, but it depends on the location. It depends on the client's requirements. So we had a discussion with the railway, but we realized that the geometrical constraints point of view, we have two existing lines, but part of this Colombo Suburban Railway project, they want additional lines. So the geometrical requirements changed. That's a starting point, right? And we need to provide provisions for these lines being done for the electrification. So then they have set out certain parameters. Let me summarize that quickly. Horizontally, as you see that you have existing lines, and then you have new lines. Then the parameters are different. That's one of the geometrical requirements we have to abide by. Vertically, of course, because the trains will be electrification lines, and then there's a certain height requirement. So we have to go with 6.6 clearance. What important thing is, they have vehemently denied to have any piers within the railway boundary. So no piers. You cannot have single pier within that. It's ruled out, right? So what we ended up with, that then these are the design requirements we ended up with. The requirement as such, as I said, told you that there are 4 locations, VD4, VD9, 19. But I'm going to talk about that VD4, VD19. As you see, just want to highlight one point. The clear span is about 70 meters, right? That's, just think about that. And then because it's in a curve, and you need to provide the provision for future widening, and you need to provide that clearance requirements, horizontal and vertical, and also high flood level. And as I mentioned, no piers within the railway boundary. So you ended up with many challenges. How do you come up with the structure to suit for these conditions? Now, this actually takes me to a little bit further about option identification. This is where I've been talking about it. Before that, I thought I just wanted to summarize what is the difference between pre-tension and post-tension, just for your, I know that you've done that many times in the university, but just nonetheless, that this what we say, you stretch it, you cast it, and then cut the tendons. You put the pressure back into the system, which enhance you to materialize, getting greater spans. That is actually pre-tension. And then there are a number of beams, I-beams, U-beams, and there are so many, right? In the industry, you will be able to find. What is post-tension? Post-tension has the options for the designers to lay the profile, the tendon, the way you want it, right? Because as you see, if you look at the bending moment diagram, then you can lay your cables along that line so that you can get more benefit. I think the beauty is that the post-tension or pre-tension, because of understanding or advancement of that high-strength concrete as well as the high-strength tendons, that actually give us to have these bridges, right? We'll come back to it a little bit later. Now, I told you, like, one thing you remember, that 70 meter span, right? Now, this is called the option identification, which types for economical span. I find this slide very fascinating, mainly because that as you see from here, you have certain spans, and for a certain span, you have certain structures suitable. Now, if you look at the reinforced concrete slabs, that is economical up to 25 meters. I mean, if you go for a little bit more, it will be heavy structures. That's not what we want, right? And there's another one, I would go neck to neck, is the span to depth ratio. Now, for example, if you look still with the reinforced concrete, now typical span to depth ratio is 17. Now, what you have is here, let's say 25, right? And then you will be able to work out what is the depth you need for that particular span. So by looking at this one, I would say that we ended up with, for that 17-meter span, we ended up with post-tension concrete box girders, steel, and steel composites. But of course, we are not going for the cable supported suspension because it's way above and is catered for different spans, right? So straight away, without doing anything, you get an idea what kind of structure is suitable for this location, don't you? And also, if you are doing that pre-release design, and this is, there are so many documentation available. Like, for example, these are pre-tension concrete beams. And the beauty here is U1, U2, U12. There are a number of sizes of the bridge, the beams, sorry. And then color coding says the spacing of the beams. And that chart gives what are the good spans the beam can take up. I mean, of course, there are companies, CESL and state SDNCC, and they develop that I-beams and etc. But there are also some charts. So these are very good things. And then I would say that if your company is, we have company procedures and company IPs, they have databases. You can refer to their databases and see that similar structures and get a good idea about that the suitable spans as well, right? Now, having known that, like three things I would do is that can I get an appreciation of what's happening around? I mean, in Sri Lanka, we have Kadawatha Interchange, Port Access, Port City, I mean, LRT is coming up and New Calendar Bridge. And of course, you can refer to these projects and see the sizes and etc. You get a feel of it, right? And as I mentioned to you, that hands-on experience is vital at this stage. And then the important message I want to give you is ECI, early contractor involvement. What is it then? I mean, it's a design and build project. That is the beauty of having this ECI, because you get the opportunity to talk to the contractor. You identify their technology, you identify their capability and the speed of construct, everything you can talk to them. And for example, then I work for a project in UK, which is M25, it's a big motorway project, it's a widening project. So the Atkins, the company I work is the designer, and then the contractor was Balfour Beatty and Stunts. There's a huge cost penalty if you don't do it right. Like especially the time constraints is very tough, because if you slip off that target, this is one of the busiest motorways in UK, and the highway agency equivalent to RDA, they put actually huge penalties. So they wanted to finish this in time. Then the idea was we had to sit down with the contractor and come up with this the cost-effective, efficient, constructible structures. So that had happened. So I would say, and if you are working on a design and build contract, and especially if you, in this instance, the MCC was the contractor, we had the opportunity to talk to them and identify a number of options. And there you have another areas, like I touch upon a little bit later, this bearing expansion joints, because you should know that right up front. Then the changes to the structure would be fairly minimal, right? And why you want to have ECI? Because it gives the opportunity to save time, mitigates risk, and it's a joint up effort at the end of the day. That's what I feel. So having talked about these things, so we came up with these three options, right? So post-tension concrete box girders, steel composites option, and then there's another option which I talk to you in a minute. And based on these facts, the post-tension concrete box is now people you've seen that it's happening here, and it's fairly fairly standard structure, put it in a way, but it's if you handle it very carefully. This is one of the projects I worked in when I was in UK. It's for Aberdeen Channel across the Hong Kong Channel. It's about main span was 115. You see that the middle, the depth is shallower. Then when you come to the piers, it's higher, mainly because, as I mentioned to you, if you can remember that two slides, that is the span to depth ratio and the economic span. Based on that, you will be able to work out, but without doing any calculation, what would be the right parameters. You get an understanding about that. So we thought, okay, that structure suits here well, because here the green line shows the boundary, because you can't put any piers in between. The piers are outside, hence the box girder post tension was an option. Then, as you see, is another picture of that. The red one is the clear boundary, the railway requirements, vertical and the horizontal. And as you see, it's not a perfect curve, but I come back to it because there was tight constraints of the height. And otherwise, you need to raise the profile, which has another economic disadvantage. It needs land acquisitions, and it could have so many repercussions. So we have to deal with this available height, what we given, right? Steel composite options, yes. This is very famous in UK, and you have steel girders, ladder structures, and very efficient, and primarily because the installation is very quick. To be honest with you, that there are heavy cranes are available, then you can use it. And but again, remember that the slide I mentioned to you, you will be able to work it out, what would be the economic sizes and etc. And with this one, one of the things you should also consider is the durability aspects, the painting systems, the regular inspection, that is also required in order to come up with that. Do we have that system in place here? That's a question that you have to ask yourself. And how the maintenance system is developing in Sri Lankan context. Are they rigid enough? And otherwise, it's like your car. If you maintain your car well, you have a long life. Otherwise, it will rust and it will go, right? These are the stuff you remember. When it comes to steel composites, and yes, we have a number of types. One is the closed steel composites and open composite, which is a classical one which you see in many European countries, right? The good thing about that one is it has a very torsional resistance rather than the other one. Of course, the eye ladders are also good, but then you have to have lots of braces throughout the time, line, and intervals would be varied. But whereas for this one, which is good, but I think there are key areas you need to satisfy, which is the plate bending. I mean, things buckling, of course, lateral torsion bucklings, all needs to satisfy. That's what you have a number of stiffeners inside this box. For example, then I had a look at what's happening in the New Caledonian Bridge. There was a span. If you just pass across the baseline, there's a crossing which the span is 78 meters, right? And the box itself, where the height varies from 2 to 2.9, the middle one 2. And I thought, yeah, this is a suitable option. And while talking to the contractor, they also proposed something on your right, which is a single box, right? So we had lots of discussion about this, and I'm just stating very quickly, but there are so many discussions and understanding the pros and cons of these the arrangements. These are some of the pictures I took when I was, thankfully I had an opportunity to go and visit the site, and the New Caledonian Bridge. You see a certain number of the stiffnesses are there. Yeah, because the stiffnesses are required in order to prevent that plate buckling, right? And also the workmanship is very important, especially when it comes to detailing. detailing, and also in the contractual stage, you need to put a lot of effort for monitoring this, the workmanship, because there are a lot of building are there. So you need to provide high provisions, high MPIs should be the status and etc. So that's only then you get the right product, and also the painting system. So certain areas you need to think about when you come up with the steel structures, right? But when the standards are there, when the specs are there, maintenance regulations are there, it's easy. That's what the UK are there. It's like a bread and butter for them. There are so many structures in steel. We can actually do the similar thing here if the process is there, right? And this is one few pictures because I'm passing every day when I go to the CP through the bridge, and I was fascinated to see day by day the progress. I took some pictures. This is one of them, as you see. So I thought, why not? We can think about a similar one here too, because as I showed here, we have a certain requirement, 70-meter span, but we can come up with a nice 2 or 3 boxes. That is an option. Right? So there's lots of thought process went in to think about an option here, right? So this was an option. Then the last option I want to say, this is, I got this idea because when I was driving through in Cambridge, there's a town called Girton, and the one circle is source, two lines crosses each other at an angle. We have a very similar situation, of course, not two bridges, sorry, 2 roadways. One is a railway line in our case, and the other one is the bridge, right? So what they've done is they came up with this I-gird arrangement. It's not a perfect, I would say, some part of the bridge would not be utilized, as you can see here. This 3D view of that, the concept being developed. This is the central expressway going through underneath the railway. The picture below shows how we stack the girders. Girders are not towards the direction of the traffic, but it's kept perpendicular. Mainly, we want to satisfy the clearance requirement, as you see in this picture. That's considered to be an option, but is technically feasible. Aesthetically, you can argue a few things, but commercially also, I don't want to quote on these things, but you need to think about these things. Right. Then and all, like you saw that 3 options, and then while discussing with the contractor and all the stakeholders, it came that post-tensioning concrete box girder probably be the good option, kind of, right, at this stage. So we wanted to explore a little bit more about that concept. One of the important things for post-tension box girders is the construction. This is what I want to take you to the next part of the presentation, where the erection methods. Because the analysis changes with the type of construction. Now, predominantly, that we can broadly categorize that the post-tension box girders are balanced cantilever methods, incremental launching method, and also full staging. I'll discuss this in a minute, right? So these are the very high-level aspects. Now let's talk about the balanced cantilever. Here, if you happen to pass the New Colony, you would have seen that the bridge being done in this fashion, the balance. Of course, there were cables. If you just forget about the cables, that's the idea. And what it says here is that each and every stage, you have to do the pre-tension, post-tension. That's how you stitch it up. And sizes may be vary 2 to 4 meters, and it all depends on the crane capacity. And what I want to emphasize is large number of cables are there, and tendons needs to be terminated at certain locations. These are the key aspects of the box, right? But analysis is complex, mainly because the long-term effects, creep and shrinkage, and temperature and things like that, because it moves. As you move, you get the cantilever and it deflects. So finally, when you do that stitch at the middle, you want to have a perfect balance. That's why the analysis is very rigorous. You have to make sure that is a proper match. Otherwise, you get a displacement. And we have sophisticated software that we can handle it, and that's not an issue if you play it well, right? So let's have a look on the balance cantilever again. And as I mentioned to you, there are two types. What is called the cast in situ. Cast in situ may be useful, especially when you process the rivers, because you can't have formwork underneath, right? And then the formwork itself form the next stage, and you cannot go wrong. And once you do the first stage, you have to do the stitching. By the way, you won't be able to see the tensioning inside. People can walk inside. The box is such that big, people and the operations, the tendon operations will be inside the box, right? The other one is what you call the segmental operations. Now, this is what you see at many places, even in Sri Lanka, thankfully. And you construct it, and there are two ways you can bring that piece. One is a mobile crane. It depends on the size, as I mentioned to you, and the location. Or if it is on a river, still you do that. You can use the barges to bring up, and then you can raise it up. That is also feasible. The important thing I wanted to tell you is that these segmental construction, that these pieces are stitching together. You have to have a female and male joint. They are stitched. That the picture at the bottom at the left is that what it shows you the shear keys which transfer the shear. And say the structure is straight, then you'll be able to have a precast segment without an issue. But if the structure in a curve, it's very difficult. So we do what you call the match casting. The formwork itself can be adjusted to suit for the next cast. And that is the way people use. And how they stitch, use the epoxy, and then you get it into the pieces and do the post tension, right? And the other one, as you see in the right hand picture, is uses the gantries. Gantry also a possibility of using. Now, what do you mean by incremental load method? Now, these are some of the pictures that I took it from internet, and this is from the Port Access City. By the way, if you want to see that, I visited a few days back, you can walk around, not in the port city itself, but when you drive around, you'll be able to see these. Gantries are there. I really encourage, if you are interested, go and have a look. And what it says is use the gantry, you lift it up, and then you get the post tension, and then finally use the post tension. Then the other option is the full stage. Rather than worry about this stitching together, you do a simple thing. You do a formwork, and you do cast the box itself on top of it, and do the post tension. Here, the analysis is going to be changed because you'll be able to get the longer cables throughout. The analysis will be simpler than the other one because you don't want to worry about this the changes of the deflection of when you go to segment construction, right? So that's one area. Just excuse me. Okay. How many minutes I have? Okay, yeah. Right. So getting to still I'm talking about these considerations. Articulation. What do you mean by articulation? That is also a very important aspect of a bridge engineering. Now, if the bridge is constructed and due to creep and shrinkage and temperature increment or decrease or differential temperature, it will move. It will move, right? How you facilitate that movement? If you have a portal frame structure, if everything is fixed, what would happen if you would not allow that movement to take place? You get high concentration, and then it will be an economic solution because the massive forces will come onto the substructure. to the peers, and finally to the pilots. So you have to provide what do you call these things, bearings, right? Which is very important aspects, because don't think these are a piece of rubber, because I talked to a engineer and the full name, but say, why are you worried about? It's a piece of rubber. But that's not the case, because rubber itself has that the elastomeric bearing, the one at the right, it has certain steel plates inside. There's a certain way of designing, because you need to facilitate that movement, right? The size, everything matters, how you do. What happens if you don't provide it? Have you gone to one of the very old bridges, under the concrete bridges? Did you see some cracks on the abutments? Why? Because this is not functioning well. The forces are getting to the abutment, which is not good. And then you start developing this cracks. So it's up to the designer to make sure the structure is stable. You need to find out which location you have to make it fixed, which location you have to make it movable. If it is a curved bridge, this challenge is still there, but you have to make sure you identify right bearing at right location. The one at the top is the one is we call the spherical bearing, because it provides a 6 degrees of freedom, which is really good. You can have number of phases, you can have movements, rotation, and things like that, right? So please bear in your mind that this is an important aspect. Then option identification comes to expansion joint. I told you that the length of the bridge is very important, because the larger the length, the larger the movement. Now, if you go in the Central Expressway or the outer circular, you see that certain intervals you have this expansion joints. In Sri Lanka, I think most of the expressway systems, either we use the strip seals or this rubber type of expansion joint, right? Now, one picture that I want to show you, the top one, say your span is like about 150, 160, something like that, then you have to have modular joints. You have to have number of them, because otherwise you cannot cater for that movement, right? That is also a decision you have to take while doing the design. Okay, right. Let's touch upon these areas very quickly. Now, if you are a designer, you please take care of that health and safety. When I would say that about 15, 20 years back, yeah, health and safety was there, but now, while seeing what's happening in Sri Lankan context, actually it's improved, I have to admit. But there are so many things you can improve as well. Like, I don't know how many people telling the truth, like if you look at the big scale projects, but I heard that still there are certain fatalities occurring. So, no. Now, my question to you as a designer, would you ever put someone at risk? You see that managers, some construction managers, they ask the laborers, go and do the work. They don't ask themselves whether is it a safe place for you to do and work. Why you should put someone else at a risk if you don't want to take that risk by yourself? That's the fundamental of health and safety. Everyone needs to go home safely. You have a family, everyone has a family. Why you, the labor, should not go home? That's what the bitter truth of health and safety, right? I would say that in a context, the awarding contract, that is some area we have confirmed on, and you have to give marks. It has to be included in the tender stage. This is what's happening in the developed countries. The marks will be low if you have the low health and safety report. Sometimes people lose projects based on the health and safety. That's why they put a lot of effort to maintain high standards. Right? I like this one, which is called the ERIC. We call the ERIC model. Called eliminate, reduce, isolate, and control. Some instance, of course, projects that where if you see a risk, you try to eliminate. That's the first stance. If not, try to reduce it. If not, you isolate it. If you cannot do that as well, you have to manage it, control it. That's a basic thing. I don't want to go in details, but I know there are guidelines, construction, the health and safety guidelines here. Management system should be put in here, and etc. Right? In UK, like what we do, we call the health and safety risk assessment for each and every aspect. The one side is probability of occurrence of that risk. On the right hand side, on we give a severity. The one you see in the red one is the most dangerous areas. You don't want to be, because it's catastrophic and almost certain that it will happen. No, you don't want to be there. So what you need to do is, if you identify an activity, you come up with a mitigation systems, try to go away from it, try to go amber and green. Each and every phases you should do. I personally think that is part of the culture. Should people, the perspection towards it, that has happened. And in a designer's context, that we developed what we call the SHE box, safety, health, and environment box. If you see that very critical items, we show that into the drawings, because contractors should be aware of there are certain health and safety requirements or issues are there if you not follow the sequence. So we translate that idea to the contractor in that way, right? Or of course, you can use method statements, and there are a number of ways you can do. This is a designer regulation as part of CDM, and I know that I don't want to get into too much here, because there are certain standards in Sri Lankan context, right? But emphasis is that is very important. Yeah, this one is one of my favorite pictures. I've shown this number of forums, but you see on your left, this is what you design. On your right, what sometimes you encountered on site. You should know that this can happen, right? And as a good designer, what fundamentally wrong sometimes that what I see at a certain degree, that young crowd coming from the universities, and they confine to the design officers, not knowing what's outside. They should know the difficulties. Why on earth you put an employee at risk like this? Do you think about it? And don't specify 40, right, if possible, because it's heavy. Have you seen that? You touched it? Go and have a look. How people struggle, the employees struggle to bend these ones. So you use the appropriately, right? That's the area I want to emphasize here. Okay, I talk about a lot that the process. Okay, now we come to the option selection process. I like to see this happening in Sri Lanka most of the project. We call the option matrix, including key considerations. What it gives is that you identify the options, you give marks for number of areas. You have to give marks for the technical feasibility, commercial feasibility, is the risk, construction feasibility, time, right? Of course, you can't see many here, but yeah, this picture you'd see. Then you have a system to find out this option suitable for that location. The decision won't be taken by independently, but it has to be discussed with the stakeholders like employer, contractor, everybody, right? This is what I wanted to emphasize. The whole process you end up with what you call the optionary study, otherwise a value engineering study, is an economical study, which gives the best option for you. Now, coming back to the project that what we talked about, and we talked to the contractor. They done a similar thing in Kadavada interchange. They have this big formwork. That one of the key requirements, because they use the full stage. They agreed that some of the material that can be used And hence we selected the post tension box girder would be the suitable option here. But there are a number of considerations we took into took on board. For commercial reasons, I can't disclose of the commercial aspects, but nonetheless, that is probably you end up with a very elegant structure like that, right? Thankfully, collaboration with the contractor, right? Where are we with it? I think we completed all the design, fully done, is about to construct, right? But let me take you to the next step very quickly. Detailed design. Now, you identify everything. Now you want to do the detailed design stage. What do? You do the job, start the job, right? That's important. How you start the job? Because I don't know whether you come across this, the document VD/20, VD2/20, which is a guideline. It gives the technical approval of highway structure. I really recommend this needs to be referred in every project because it gives the opportunity for the people to do the job right. Very start from the start the job right. Now, that document states is you develop what you call the AIP, which is the basis of design. You can do that for any structure. It includes all the details of the structure. It's a live document, by the way. And why I say it's a live document, because as the project progresses, there are things can change, and then you would include that in that document, and then you need to get the approval from the employer. Then it's set, and it's good for your claim purposes as well if you are wearing a different hat, because it's been agreed. And any changes, it's feed into change control, and then it prompts a claim. So thankfully that we implemented that for our project, and there are a number of AIPs. I'm so proud of that. I managed to introduce many in this Central Expressway one. Then that document also talks about the what you call the checking process. Depending on the structure, we have certain categories, category 1, 2, 3 as such. The complexity arises the fact that you have to have independent checking. For example, if the structure is so complex, then you have to do an independent checking with a different party, right? I'm not going to get into detail, but category CO means self-checking. One is that you can do a different party within the design team itself. Likewise, the intensity increases, right? Now, why I want to emphasize is that, I mean, the picture above is, this is suspension bridge in USA, in 1940. It's a Tacoma bridge, it's a famous collapse of a bridge. It's actually due to resonance. And this picture above below right is one in India. I mean, do you want to be part of this project? Just, why do you want to be part of this project now? It's a failure. That's why I'm saying the emphasis should be for your checking. Do your self-checking, due diligence, and also checklist needs to be prepared by the designers itself. There are industries. For example, our company has a nuclear industry, right? Unbelievable checking. My God, I can't explain how many checkings they do, right? Because the catastrophe would be huge for the humankind. You can't make mistakes in that nuclear industry, can you? No. So that's why there are steps needs to be followed through. So that culture should be inculcated in our process as well. The checking. You do a design, have you checked that? You ask yourself, okay? Anyway, so this actually takes me to the last part of my presentation, which I will touch base on some of the aspects that the detailed design of post-tension box girders, right? So, yeah, I would say that broadly you can categorize the substructure and a superstructure. It's not like a normal bridge. Of course, when you take substructure, you need to know about the soil condition. And one of the professors actually told me when I was in uni, and forget about everything, you should know where you're sitting on. That's True. Because anything will be built. I mean, you need to know what's the ground conditions, right? If the ground conditions are not right, and the structure will collapse due to a number of reasons, the settlements, movements, and etc. So you need to work with the geotechnical engineers very well. And then with that, then of course you go to superstructure. There are reports, the diaphragm and things like that. Let me touch base on some of the aspects in my next few slides. So modeling, when it comes to modeling of structures, I think the reports gives good guidance. Now, if you look at 1992 part 1, and it gives the global analysis aspect, idealization structure, that some guidelines are there. You can choose the appropriate one here. And when on your right-hand side, you have line beam models, village models, and etc., depending on the complexity. But for this instance, we choose two. One is a line beam and a village. Line beam is the one that we do primarily because it gives some idea of the behavior. But then the village being developed, which gives the torsional effects and etc. Right? Now, we use software called Midas, which is I'm not promoting any software, by the way, but this is what we use. But any software would do. But nonetheless, that Midas gives options to tackle the long-term behavior, which is good. Because otherwise, when you look at the post-tension beams, continuous ones, you have secondary movements and things like that. It handles well, right? One aspect I want to highlight is the soil structure interaction. Because you talk to the geotechnical engineer, you work out the springs, the bearings, skin friction, and the lateral springs. You add them into the model. It gives the actual behavior. And also, you need to look at that articulation I mentioned, where the structure should move and etc. And that also needs to be included in this model. Then only it represents the actual behavior of the structure, what you would expect on the natural way. So any software that there are areas, I would broadly say properties, boundaries, loads, and then finally review. I mean, not only Midas, you take any building codes, ETABS, or anything you talk about it, you need to follow this, right? Because the stiffness changes, you change the parameters, behavior changes, right? I mean, if you are doing hardcore structural engineering, that's what happens. Yeah, this area is very interesting area of that because I told you that we had a challenge. We wouldn't be able to get that nice curve because of the height requirements. So we had a kink. So there you had to be very careful about the shear capacity. We did a trick which discussing with the contractor. We internally increase the thickness as you go through. This is what you see in the picture here. And in fact, I was so confident that we can go this one because UK that I had number of similar type of bridges which I referred to, and this is one of them. And but their stress concentration is there. So I would urge, like if you are doing this post-tension box girder bridges, maybe applicable for any as well, that if there's a sudden change, that area of concern always. Please be mindful of that area. Right? And one of the key areas of a post-tension box girder is a diaphragm. Diaphragm, again, if you look at the Euro code, it gives proper guidance. It gives the, they use actually a cut and tie method. Like you have the support conditions, when the loading and where you find out tension areas, you need to provide reinforcements. Right? Likewise, if you have a compression strut, you didn't make sure the compression is not exceeding the capacity of the concrete. Likewise, right? And that guidelines is pretty much there. I mean, there are two aspects. One is with the hole, without hole, because inside people needs to go through one side to the other, and that's what you see on the right-hand side picture. Yeah. Another extension is you can have transverse post tension as well, because if you look at that picture on the schematic picture, if you just think of the loading, top will be under tension. You can provide transverse tendons there. Again, I would say you'll be able to use strut and tie method here. If proper guidance is there, please refer to the Eurocodes. And the majority of the time, this is very highly congestion area. There's so much reinforcements, right? This is what project that I worked for when I was working for Atkins. We used beam modeling because we wanted to identify clashes, and because the amount of reinforcements is enormous. Hence, we developed this model, and as you see, it's very useful. And then, I mean, otherwise you need to visualize when you review the drawings. You need to think about all the areas where there's no clash. I had to spend a lot of time for this project also not to make any clashes to happen, right? Also, another key design area is that end block. End block is where when do the post tensioning, at the end, you have the big anchorages. The whole force will be transferred to the box itself at that corner. And what eventually happens is there's a lot of stress concentration can happen. You know, due to Poisson ratio, when you apply the force at that corner, it will expand, and generally it tends to burst, and then you need to have right confinement. There's a guideline on Syria. I would encourage those who are working. I know that many of them are not. For record purpose, I'm saying that bursting, equilibrium, falling, you need to satisfy that. That guidance is there. But in the Eurocodes, again, suggest you can use strut and tie. That's also another options you can use. Or if it is very complex, I would people tend to use this what you call the solid modeling, and you do solid finite element modeling and check whether the stresses are comparable. Right? There are options available. Again, coming back to the in-block design, I would say what I want to emphasize is these geometrical clearances. You have to put a lot of effort here just to make sure the jacks will fit. If the jack won't fit, it's a disaster when at the last stage. That's why that benefit of having ECI, early contractor involvement, because some project give the opportunity to talk to the contractor. Contractor has the opportunity to talk to their preferred supplier, right? When you get the preferred supplier, then you get the product. Then you check whether that product fits here. This is what we did here. And then thankfully, 100% sure this will be fit. And I know so much time we talked about it, otherwise it will not would be a catastrophic failure. If you can remember my initial one, you know the change, the cost versus time change. See, if you happens at the at the latter part of the process, the rectification will be very huge. So please bear that in your mind, right? The one of the classical features, the other aspect is these in-block blisters within the box itself, inside, right? Their termination should be there. People can walk through, and of course, the health and safety is very important because you are working under confined areas. The less air control should be checked. What I want to emphasize is this. This is a very interesting area where when you actually terminate the green arrows above, which it takes the cable out. Right? Sometimes, depending on the post tension box, you have double curvatures. One curvature going in the vertical direction and the horizontal direction. So, this is a very important area you have to be careful of. Otherwise, of course, we can tackle. We are engineers. We know how to tackle. We put right amount of hooks. And that had happened in some of the projects that previous when I was working. And then there's a guideline being written on that. Okay, so that sums up my the design issues. Like I have two more slides. I wrap up this one within very short space. I know you're conscious of the time, right? This is the future challenges, right? I would say that we are moving in the 21st century and it's happening in the digital transformation. We have BIM and 3D visualization. My question is that any organization you are work for, do you have the right documentation? If you want to assess something, can you get the requirements very quickly? I certainly, I think you'll probably be struggling. Now, that's what the digitalization coming on is a BIM model is the trend now in the society and the industry, right? It will come, it has to be the case. And also online monitoring system, you can use latest technology such as drones, fiber optics, crack identification. The one of the good example is that for cable stage bridges, you can look at the strain requirements offline. And we use this technology for offshore structures as well. We put strain gauges, see that the structure moves its dynamics, that you work out the natural frequency, right? If something different, you see something happen to the structure, likewise. And I want to emphasize this one, that this is what I want to say, the third bullet point, the develop early warning systems for assessment modification. And then naturally we are moving to the new materials such as carbon, glass and aramid, because the technology improves and there are guidance on that. So please look into these areas, right, for future developments. Okay, let me wrap up this with some of my concepts now. This is my personal view. I feel that there are areas we can still develop in bridge sector in Sri Lanka, knowing both sides of the spectrum. And it's not matured yet, like buildings, right? There are areas you can improve. You are doing, please try to follow the procedures that I emphasize. Whether you can be wearing different hats, you can be wearing clients or contractor, and finally, if you know the process, what needed to be done, try to get it into the procurement rule. So that's what I want to emphasize. And the second one is the value engineering. We call it optioneering studies, and that has to be done. That has to be done for many projects. Then only you get it, the right response. And now I also wanted to say the procurement strategies. See that without policy, without procurement, nothing can be done, right? If you don't get the right specification written, and you won't get the benefits, right? And it's very difficult to implement changes later if you already signed the contract. So there's a lot of emphasis should be before that. That's what the expert knowledge should be there, right? I think the last point is that long way to go. I think which sector will blossom here, and we need wider support, not only from one single entity like designers, architects, and all the stakeholders should all work hard and get this through. So with that note, then I conclude my presentation. I hope you enjoy, but yeah, and thank you very much for giving me this opportunity to present. Thank you.
Thank you very much, Dr. Nadunanlis, for the presentation. And ladies and gentlemen, just great pleasure to have this opportunity. It was the vote of thanks today. First of all, I must, before the vote of thank, we have to appreciate the presenter, and we have arranged a small memento to give away, and I would like to invite our chairman, Engineer Kamal Punwadhan, on stage. And Dr. Nadunanlis, please. Thank you very much, Dr. and Mrs. Tangadunan. And ladies and gentlemen, this is the first presentation we conducted for the new tenure of Civil Engineering Sectional Committee. And if I remember that this is the first one that we did when we stopped the physical presentation in March in 2020. So we did I think two memorial orations. Other than that, this is the first presentation. So today is a very special day for our CNG section committee. And we must really appreciate those who come in physical here. And we had many joining with online. And thank you very much for all. And special thank goes to our person today, Dr. Nadunalis. And really appreciate and the way that you did the presentation, the holistic view, how this bridge design is done. And there may be many questions, and you can share this question in our WhatsApp group. And ladies and gentlemen, all these presentations will be uploaded to the YouTube channel of the Civil Engineering Sectional Committee. Then you can see all the presentations that we did over the last year also. And thank you very much, ladies and gentlemen, those who are joining here. And thank you, the IESL and the WXC Secretary here. And we'll meet with another presentation in future. And those who are joining with the monthly meeting of CNG Sectional Committee, please, you can join online here onwards. And we'll thank you again. Have a safe journey back. Ladies and gentlemen, we'll take a couple of minutes, and do we have any questions right now? You can on the mic and you can ask now.
That's one question for design participants. Another question, design consideration shall be both of things. Step by step, we strengthen different kinds of cables. Then similar length of cables we stretching at once.
Yeah. The question is related to, actually there are two types of construction that I mentioned, the segmental and the full stage. Now, when you come to a segmental construction, of course, you need to ensure that the enough force tension will be applied so that it will stick together, right? And you need to apply enough such that the deflection also needs to be controlled appropriately. And also it depends on number of strands available, because there are certain number of I would say anchorage are available within that boxes. But whereas when you consider the full one, the full stage, you can have one cable going from one end to the other. And if the lengths are bigger, then you can have connections as well. And of course, the losses will be there, but you need to negate and find out what is the right amount of occasional pressures, post tension. Yeah.
Thank you. Any questions you can share with the our Civil Engineering Section Committee. You have, I think, our WhatsApp group. We have WhatsApp group, or you can send the email of Civil Section Committee of the IESL. Then we can direct those to the today the presenter, Dr. Nadunalis, and they will answer accordingly. And ladies and gentlemen, then we'll stop today and have a safe journey back, those who are here, and good night all. Thank you.